This is the best image I've seen all week. It's so good it brought tears to my eyes, and I think I know why. But before I tell you about it, let me tell you what it shows. It shows a spiral galaxy that is rich in supernova. That's the stuff that makes our sun and all the other stars. This one is called M82, and it's special because it has a lot of star formation going on. The image was taken by the brand new instrument on board the Hubble Space Telescope. When I saw this image for the first time, I thought, wow, the universe is so beautiful. And then I thought, how can I make this even better? Well, if we zoom into the image, we can get an even closer look at the details. Look at those beautiful shells. They are expanding like ripples in a pond after a stone was thrown into it. These shells were created by a single supernova explosion, and they are moving at 7 million kilometers per hour. Just for comparison, that's as fast as a jet fighter. At this distance, the galaxy is 32 million light-years away from us. So when we look at it, we're seeing it as it was 32 million years ago. And if we go further out, we can see more of these shells. We're getting a 3D view of them. Some are almost spherical, others are more like elongated bubbles. They probably formed in different directions with respect to the Earth, and if we measure the distances to them, we find that they extend for 1,000 light-years in all directions. That's as far as the Earth is from Alpha Centauri, the next star system after the Sun. But here comes the weird part. If you look carefully, you will notice that there is no space between these shells. They touch each other. If they were bubbles, there would be some space left between them. The reason they touch each other is because there is not just one shell. Each ring is actually made of many rings. It's like layers of a wedding cake, and in total, there are at least 20 of these structures around the galaxy. These shells must have been produced by supernova explosions that happened in the past. When a massive star dies, it explodes and blasts material into the surrounding space. This material forms a shell. When another star explodes nearby, its material will run into the shell and either bore a hole through it or push the shell outwards, depending on the strength of the explosion and the density of the material. In this way, the supernova explosions drive the interstellar medium out of the galaxy and create these beautiful bubbles. The interesting thing is now that the gas does not only expand outwards, but also inwards. This is the first time that we have seen such a large-scale galactic wind. What's driving it? Most likely it's the star formation. As the stars form, they create strong stellar winds that blow away the gas. And that gas is then accelerated by supernova explosions, until it reaches speeds of up to 40 million kilometers per hour. At those speeds, the gas can travel from one side of the galaxy to the other, within just a few million years. So what do we learn from this image? First, the universe is a beautiful place. Second, supernova are the engines that drive the evolution of galaxies. Both are true, but to me, the image tells a third story, and that is a story about death and rebirth. If we look at this image, we might think that all those supernova explosions are gone. They happened in the past. But this is wrong. Every point of light in the image is a supernova. They are still happening right now. Yes, every single one of them. All these stars are being born right now. Stars live fast and die young, and their life cycle is measured in millions of years. The stars that exploded to create the inner rings of this galaxy are long dead by now. But the stars that exploded to create the outermost rings are still shining, and eventually, the stars that are currently exploding will also die, and new stars will form in their place. This is a beautiful image because it captures a moment in time, a moment where the past meets the present and the future, where dead stars form new stars, where one day new supernova will explode again, creating new shells. I said at the beginning that I knew why this image brought tears to my eyes, but I lied. I didn't know. I was hoping that you would help me figure this out. And while I read your comments, I think I found the reason. You see, there is something very sad about a supernova. It's the death of a star. And in the image, we see so many of them, so many dead stars. But at the same time, the supernova are the building blocks of new stars. So perhaps what I see in this image is a kind of hope, the hope that even after death, new life can begin. Or perhaps it's just that we keep finding new and ever more creative ways to die. And that's what the image really means to me. What does it mean to you? Tell me in the comments below. You see, I don't think there is just one correct interpretation of a scientific image. Images are open to interpretation. And so if they weren't, science would be boring. Last year, I did a video about another image from the James Webb Space Telescope, this one showing the pillars of creation. And one of the comments that I got was, who decides which images the Webb will take? And the answer is that scientists don't decide. The targets are decided by astronomers, and they do it democratically. Well, almost democratically. How does democracy work in science? Let's have a look. Scientists use a system called peer review to decide which papers get published. That works like this. An author submits a paper to a journal. The journal assigns it to an editor, who then asks several other scientists in the field to read the paper and to give their opinion on it. These scientists are called referees. and they can ask the author to make changes to the paper or they can accept it as it is. Referees are volunteers, and they do the job for free. They do it because it's their civic duty. But how do they make sure that the referees are qualified to judge the paper? They don't. The referee system works without any registration or accreditation. Anyone can become a referee. In fact, everyone should become a referee, because once you've gained some expertise in your field, you have a moral obligation to share it. If you want to learn more about the basics of solar panels, superconductors, or neural networks, you can take courses on Brilliant.org. Brilliant.org offers courses on a large variety of topics in science, computer science, and mathematics. All their courses come with interactive visualizations and follow-up questions. Some even have executable Python scripts or videos with little demonstration experiments. Whether you want to know more about renewable energy or quantum computing, Brilliant has you covered. Yes, it's true. Hubble surveyed a rich cluster of galaxies. Last year, the James Webb Space Telescope looked at a cluster of galaxies that contains 40 trillion stars. The data it collected helped astronomers to map dark matter in the universe. But I bet you want to know more about the image that Hubble took of M82. The image was taken with Hubble's near-infrared camera. This is the first time that the camera has been used to observe an astronomical target. It will enable Hubble to see things that are too faint or too far away for the aging telescope otherwise. To get this image, the camera was set to see light with a wavelength of about 1600 nanometers. This is in the near-infrared, where the light has a bit longer wavelength than what the human eye can see. To collect enough light for the image, the camera had to expose the target for a long time. Altogether, the observations of M82 took about 40 hours. That sounds like a long time, but it's actually a rather short exposure time for Hubble. What you see in the image is not just the galaxy M82, but also to smaller galaxies that are close to it. All three are in the process of merging. M82 and the small galaxy NGC 3079 are so close to each other that they are interacting already. But the third galaxy, NGC 3077, is more distant, and it's just passing through. The image doesn't show this well, but M82 is actually a giant. It's 60,000 light-years across. That's twice the size of the Milky Way. Thanks for watching. See you tomorrow.